Ivan, good afternoon. Thank you for joining me for this Data Sommelier show. We are going to describe this KIP-1150 project. It sounds like a secret project with a special name, but it's about doing Kafka without disk. So I'm very curious to understand what is behind the technical features, but also the benefits of this project. So, Ivan, welcome, and up to you to share what is this project.
Yeah, well, hello everyone, and hello Stefan. Thank you for having me. I'm very happy to join you here today and tell you about Diskless Topics in Kafka. So let's maybe start with maybe a very short introduction about myself. My name is Ivan Yushchenko. I'm an engineer at company Ivan. Um, I work in a streaming domain. Mainly, I'm focusing on Kafka and some other streaming related products. I've been working with Kafka for almost 8 years now, so quite some time. So here on the slide you can find some coordinates about me on the internet. I'm on Twitter, I'm on LinkedIn. I can also say a couple of words about Ivan. So, well, obligatory disclaimer is that I am here as an not I work for Ivan, but I'm here not as an Ivan employee, but more as an open source contributor, and I will be wearing this hat today.
Yes.
But I can tell a couple of words about the company. So at Ivan we offer a variety of cloud data and streaming services. This being, for example, Kafka, this being Postgres, MySQL, OpenSearch, and other products that pretty much any developer shop needs to run the business.
Yeah, we did a meetup last month with your company, and we have discovered your offer, and you have interesting components to connect to many databases, and it's used by OVH Cloud, one of our famous French organization here in France. Yes.
Yeah, that's correct. OVH is a great partner of Ivan.
Exact. But here, this is a special project, right? This is an open source development, and it's about augmenting or making Kafka better, something
Yes.
like that. But you will give us more details about that.
Yeah, let's go. So, um, first thing, so you said KIP and the number 1150. So KIP stands for Kafka Improvement Proposal.
Okay.
So it means in Apache Kafka, it's a community governed project. And if someone wants to make a big change that is not enough to make a pull request, you need first to gather feedback from the community members.
Okay.
So, and there is a formalized process for this called Kafka improvement process. And the thing inside this called Kafka improvement proposals. So you write a proposal. It's a semi-formal document
Okay.
where you explain what you want to do, why, and how it affects current users. Is there breaking changes? What new, for example, monitoring devices you need, new metrics, new configurations. So stuff like this, like test strategy, and so everything that describes how Kafka change if this is approved.
Okay. So
And
no secret anymore about
yeah,
KIP. Good.
so so as this number 1150 is just a sequence number. So it
Okay.
means that it's used before that it was a bit over 1,000 proposals, and
Okay.
most of them were accepted.
Okay.
But
So
still,
the real name of this behind this number is the Diskless Topics. This is a
yes,
project
that
name,
is
in fact.
that is correct. So Diskless Topics is the whole essence of this. So like, we want Kafka currently store data on disks, and this has implications in clouds. And we want to find a way around this to make Kafka cheaper, to reduce the total cost of ownership for running
Okay.
Kafka in cloud.
Okay.
So yeah,
So the
that
global idea is very simple to understand. Yes,
yeah,
it's a
that,
Kafka without disk.
Yes, Kafka is expensive. So that's like if this project had a motto, this would be the motto. Like, Kafka is expensive, let's make it cheaper.
Yes.
So, like, what makes Kafka in cloud expensive? Kafka was designed for data centers. So, data centers that you own or rent, but not for clouds. In data centers, you have hardware machines, probably cut into virtual machines, but still, it's hardware that you own. And in this setup, you don't pay for network, for example. So you
Mhm.
pay it once to lay the cables and set up everything, but you don't pay for bytes. But in cloud environments, let's speak about AWS or Google Cloud or Azure or any like smaller cloud like OVH. You usually have like regions, which is like geographical zone, and inside region you have availability zones, which are separate physical data centers, which can fail independently, but the whole region remains kind of more stable and durable.
Okay.
And usually clouds charge you money when you send data from one availability zone to another. For example, if you use AWS as a reference, they charge 1 cent per gigabyte, both directions. So for
Okay.
input and for egress and for egress. So effectively, if you send 1 gigabyte, you pay 2 cents for this
Okay.
gigabyte. Oh, and Kafka kind of naturally you want to deploy Kafka brokers in different availability zones because you want to protect your business, which Kafka might be a backbone of, from availability zone failures. So you have 3 availability zones, you deploy 3 brokers or 6 brokers in these zones spread evenly.
Okay.
But Kafka has replication. And once you write data to one broker, this data in most cases is replicated to 2 other brokers. And you pay for this data transfer.
Okay. So this
Yeah.
is fact. This is the way it works today. It can be expensive sometimes.
Yeah, it can be expensive. We calculated that the cross availability zone network cost is the biggest contributor to the total cost of ownership.
Okay. So cost is one dimension, but it can be also complex sometimes.
Yeah,
Building
yeah,
a
Kafka.
yeah.
Yeah, so like managing terabytes of data. Well, because Kafka is very robust, and this project has been around for many years, and it can manage insanely big volumes of data.
Yes.
But still, the less data you have, the better, the faster. Like it's just easier.
Yes. It makes
So,
sense.
and
Yeah.
once you don't store these terabytes, you don't have to move these terabytes when the cluster rebalances, and you basically delegate a lot of headache from your own operations to the operations of the hyperscaler you happen to be on.
Okay.
So
Makes sense.
let's S3 on-call engineers worry about replications and replication lag and stuff like this. And we just use this and pay for the service.
Okay. Okay.
Yeah, so
Good.
that's another dimension.
Yeah.
So there is a number of commercial products that try to achieve this from different angles. You probably have heard of Warp Stream, AutoMQ, Buff. Uh, but Apache Kafka, like open source product, did not have this feature and did not try to address this problem pretty much anyhow.
Okay. So right now, this is a complementary feature of Kafka.
Yes. So we basically decided that Kafka needs this feature because, well, it's lagging behind the commercial offerings and it's splitting the community. So, and especially we can do this as it's like it's possible. So why not? So we decided to make this KIP, and it's actually a series of KIP because it's a big feature, and we made like mother KIP, which is currently under vote already, and several sub KIPs that describe particular aspects of the solution.
Excellent.
Yeah.
So I think on the next slide, you are going to talk about the cost, and I was impressed by the numbers. And yeah, this is something big. You can expect a lot of. Let's go this
Yeah.
way. Yes.
Yes,
Yeah.
that's right. So we of course, we don't still have like production clusters to have real data, like cost reduction data. But we run a pretty comprehensive calculation, and we try to account everything, like replication costs, costs like of network traffic from producers and to consumers, costs of
Okay.
disk and stuff like this. And we figured out that it might be up to 80% of total
Wow.
cost reduction for Kafka in cloud.
Yes.
So it's pretty impressive. It's hard to believe, but it's well, it's that's just mathematics.
Yeah, no, this is huge. Yes, it's huge, and
Yeah.
this will increase interest for this project.
Yes, and well, interest has been pretty great. People left lots of comments, and let's see how it develops further. Actually, there are a number of competing proposals now in the discussion. So
Okay, so but this
it's
is good. I mean,
yeah,
you provide some good features, and maybe you have some competitors or helpers who can provide even better
yeah,
things. So yeah,
yeah.
this
Well,
is good.
we are committed to like the best of open source community around Kafka. So that's our primary goal to benefit from this
Okay.
and help other benefit from the feature.
Okay,
And
and here I can see that there's a small expected change, 2 or 3%
yeah,
to of updates um, in order to make it work.
yeah.
So
So,
okay,
well, Kafka's code base is huge, so 2% is not exactly like 2 lines. But we expect the change surface to be small compared to the whole code base. So it's not fundamental rewrite. It's just like several strategic injection of the code that like diverts certain like execution paths to specific code.
okay,
Uh, yeah, so we like it might like the code might creep and there might be more, but I expect the original like the first contribution to be no bigger than 3%.
okay, good. So, and it's still fully compatible with the original API.
Yes, that's the whole point. So we don't want any migration process. We
Yes.
want full compatibility of the clients. So you will have just a new topic type, and that's pretty much it. You use your own producers, consumers. It might be third-party producers or consumers. Uh, everything will just work.
Okay. Okay. Good.
So that's
Yes.
ultimate ambition to not
Okay.
overburden you with migrations.
There's some architectural discussion, however, to have before adopting this, right? Because you don't need the disk anymore, so you have to think a little bit differently.
Yeah. Yeah, we can move to the next slide and look into the essence of the like technical essence, the how of the thing. Uh, all starts with object storage. So many cloud vendors, including all hyperscalers, they have this object storage product. So object storage are different from local disks. Local disk, I mean like truly local SSD or maybe network attached disks, any like block storage device. They're different in some ways. Like first way is that um, the objects. I'm not saying files because usually they call the objects. They are immutable. You cannot write like 1 byte in the middle. You have to overwrite the whole file. So this makes them like kind of impractical from uh, the same approach as it's in Kafka. You cannot apply because in most clouds you cannot even append to an existing object.
Okay.
Uh, but they also have different economy. Um, they are cheaper than disks for storage, like quite considerably. But instead of that, you pay for requests. So you pay for get requests, you pay for put requests. So that's they have internal replication. So
Yes.
like
And maybe you don't have the same latency.
yeah, of course. Yeah, that's another trade-off that well I should have mentioned on the slide. Of course,
Yeah.
latency is bigger. So on normal disks, we speak of like milliseconds or microseconds, hundreds of microseconds. But on block storages, we speak about hundreds of milliseconds.
Okay, so it
All
means
right.
that maybe not all use cases are candidates
Yes.
for this enhancement. Yes.
Yeah, that's of course. So that's since we provided that an option, but not as a replacement for normal topics, uh, everyone who can benefit from this would benefit. Otherwise, will just not notice it.
Yeah,
So that's the
yeah,
thing.
very interesting. So
Yeah.
the initial conversation is about which use case can migrate or get the benefit of this new feature. Yes, but
Yes.
not all of them are candidate to
Yes.
be.
That's absolutely. So, but we have a big customer base in the company, and we exposed to them, and we had lots of conversation also with other connections in the industry. And it turned out that lots of companies are willing to pay with high latency uh, in order to pay less with money.
Okay.
And, this like big reduction in total cost of ownership is like very compelling for people to reconsider their requirements for latencies.
Oh yes, exact. Money is king, right? So,
Yeah.
so okay.
Yeah. So yeah, and um, if we look closer into the like produce path, how data come from producers from the client side to the brokers. So usually, like in Kafka, the producer sends a produce request with data inside. So and the broker just writes them to disk and replies immediately to back to the producer. So this happens very quickly. Uh, but if you get rid of disks, you like have to change this. So for example, on object storage, we have put requests, and put requests are expensive. So if you, pretty expensive. If you write any bit of data that comes from the producer as a separate individual pull request, put request, you will be ruined. You will pay like all the money for this. It's astronomically expensive. So classical problem how to solve. We need to amortize these costs and like by buffering. We can have a buffer in the memory, collect requests, and when we have enough data, for example, we use this default 8 megabytes or 250 milliseconds. So which comes first? Then the buffer closes and it's uploaded to the object storage. Obviously, this is one of the point where latency is introduced. Since you have to wait before you answer to the producer, the produce latency grows. So it used to be like single-digit milliseconds, so it depends on your network and disks. But now you have to wait in the worst case 250, and then sometime until it's uploaded, and then sometimes on one last step, which I will explain later. Um, but now we don't need to do replication. That's a benefit. So we delegated replication to the object storage, and we save some money on the replication traffic.
Okay.
So the less data, yeah.
Just a quick question. Before starting moving to this or using these features, do you have a kind of calculator to estimate the benefits
Yeah,
before committing to this new feature?
yeah,
This is
that's
something you can do?
a very good question. So we like for the open source, we haven't offered this calculator yet, but we are working on this, and it will be published sometime soon.
Okay,
So
it makes
we
sense.
have it
Yes.
internally, but we want to make a nice UI and like available for everyone on the internet. So yeah, this calculator will be provided.
Yeah, I imagine a nice solution where thousands of customers will try to simulate the benefit they can expect from
Yeah.
this new feature. Yes.
Yes, of course. It very much depends on your use cases, like how much data, what's your replication factor, and stuff like this. Yeah. Well, here we have a like more schematical representation of the process that I explained, and
Yes.
on the right hand side, it's uh how the file, this object, how it looks like. So in classic Kafka topics, each partition has its own set of files. It like that contains only the data for this partition. But
Okay.
in this thing, since we collect everything in one single buffer, we have data from multiple partitions, whatever happened to be arriving in the broker. We call that shared log segment.
Okay, okay, good. I see AWS here. Did you focus on specific cloud or specific storage? I've seen S3, but does it work with
Yeah.
different?
No, actually not. It's applicable to pretty much any object storage out there. So we have three major: S3, GCS, and Azure.
Okay,
And we have a bunch of S3 compatible. For example, I believe it's called Spaces on DigitalOcean, and others have similar products as well. So it will be universal.
okay, okay. Here we have this consume part, so
Yeah.
the second part of the mechanism.
Yeah, consuming is simpler because, well, now we have data somewhere on object storage. So we need to, like, when the consume request comes, fetch request comes to the broker consults a batch coordinator. So batch coordinator, well, I haven't mentioned it yet. It's a thing that is responsible for ordering of batches. So in Kafka, everything is about order, right? So we have a log abstraction, and in log, every record has a designated place called the offset. So and they
Okay,
must be unambiguous through the cluster. So in classic topic, it was solved by leaders, but now we don't have leaders because every broker could accept writes.
okay,
So to solve this problem, we basically allow brokers to upload their data independently without any coordination, just upload the file. But then they commit this file with a new component called batch coordinator. This
okay,
batch coordinator, it assigns pretty much offsets and places in the log to each record batch. So in distributed systems, it's called separation of storage IO and sequencing.
okay. So this is part of the 2 or 3% of
Yeah,
code you have changed, and it looks like a big change because
yeah, yeah,
this is part of the core system of Kafka.
correct. And of course, it needs lots of good testing because, obviously, it's like uh, the ways how you can break and lose data is like numerous. So it
Oh
needs to be
yes.
very, very precisely tested under like property-based testing and like load testing, like various way to break network between when you try to commit. So we are doing all this.
Oh yes. How many people are working and trying to add features to this project?
Yeah.
It's a big team. Maybe you can give us a little bit of overview.
Yeah. So currently the team, well, if you scroll to the second slide, we'll have all the names of the engineers. Um, 1, 2, 3, 4, 5, 6, 7, 8. So 7 engineers and the director of the streaming domain. So, but also we, of course, like this is like only the authors of the thing from our side, from the Ivan side. But there is also a lot of people on the community in the program management committee of the Apache Kafka who gave their like feedback and comments, who helped us to shape this KIP and make it like look good and directed towards like benefit of Kafka.
Okay,
So
so
and
we can say
yeah,
hello to the team.
yeah,
Congratulations for this development.
correct. And of course, like once this code becomes part of Apache Kafka, the Apache Kafka becomes the owner. Apache Foundation becomes the owner of the code, and like everyone will be contributing. And we expect and we hope other people to come and follow the normal open source process and like start doing their contributions as well.
Okay, so this is good to mention. It's not yet an Apache project, not yet.
So well, it's basically until Apache says yes, we want this, we will take this, and then it becomes Apache project.
Okay, okay,
Uh,
good. So thank you very much for that. I think we are almost at the end of this presentation. Maybe a conclusion, a slide about this project.
yeah, like um, there are of course like lots of implementation details, but well, we don't have time. It might be a couple of hours of discussion, but some side effects, like apart from direct TCO reduction, what we get. So first thing I already mentioned, we discussed it, it's easy operations. So faster scaling, faster rebalancing. The less data you have in disk, the less data you need to move around. This is as true for this as it's true for like tiered storage, for example.
Okay.
Second benefit is more interesting. We already very deeply into the changing how the data is stored. So we um, change the file layouts. We know where every batch is. So we have lots of metadata about this. Why don't we make a next step? And instead of storing like in a Kafka native storage format, why don't we convert this into, for example, Apache Iceberg, which
Good
is a
idea.
growing popularity for table format in like big data community.
Oh,
So in
yes.
this case, your big data tools, Spark or Flink or Dreamy or everything, could read not from Kafka, but read directly from S3.
Oh, yes. That
Yeah.
that would be very great because we can see how iceberg is growing right now.
Yeah,
And,
exactly. So
yes.
this will be like single storage. It's not like we now have Iceberg connector, which can pump your data from Kafka to Iceberg, and that's it. But we
Yes.
want single storage. So
Yes.
one source of truth for Kafka, for Spark, for Flink, for everything.
That would be incredible to have this iceberg in the middle of this.
Yeah. So this is not currently part of the KIP, but the KIP is an enabler for this feature. So we want
Yes.
the next step, maybe next year, when the current KIP is approved. Next step would be like Iceberg focus.
Okay. So it's not yet in the roadmap, but you are thinking of, okay, this is a foundation. Today's this is a foundation for the next step, and iceberg is part of this next
Yeah,
step.
we want. So, and the last thing, it's less explored area. We only speculate about this. We haven't draw a design, but we believe it's possible. So, in object storages, let's say again S3. I'm saying S3, but it might be any hyperscaler offer this. It's a replication of data between regions. So you have, for example, your data in one um, region in Europe, and you replicate it to another region in Europe or in North America, something like this. So if we add metadata replication and coordinates, batch coordinates replication on top of this, we get multi-region disaster recovery. So your
Oh, yes.
whole geographical region of AWS fails in Europe, and you switch over to another region that you happen to have your data in. So it's kind of mirror maker on steroids. Or you can have a read-only cluster that is just not writing, but just reading with lower latency locally.
Yeah,
So
very interesting.
it's
And
a,
you,
it's a good speculation at the moment, not yet well developed, but we believe it's a good way
yes,
to apply some thoughts.
it's one direction. And if you mix this with iceberg, iceberg will maybe become the kind of the standard backbone for all architecture, all enterprise, and yeah, we can. I can see a lot of benefits doing that.
Yeah, that will be fantastic.
So this will be part two of our conversation when this feature is online, and we'll be happy to host you again and see the progress you made on these features. But congratulations to you and the team
Yeah,
for that.
thank you.
I'm curious to see a real implementation right now and see how end users will be happy with this new feature and
Yeah,
how easy they will jump and use this. So always happy to have some customer testimonies and see how it works in real life.
yeah. And of course, like everyone who is interested, please go to the Keep page, and it has a link to the discussion thread in the mailing list where you can join and give your opinion, maybe bring in some new requirements that you see that others will benefit from. So it's open source, it's open community. Please join.
Excellent. So thank you, Ivan, for this brief, for this overview, and talk to you soon for part two.
Yes, thank you.
Thank you.
Thank you for having me, and
Bye bye.